We are Cat Zero, and we are presenting our renovated Lake Flato building. Our team consists of Alejandro Gonzalez, team leader and architect, Corbin Mills, electrical lead, Maya Hernandez and Juan Azua, mechanical leads, Grace Rice and Robert Moore, structural leads, Grace Song, construction. The general project schedule breakdown is based upon the ASHRAE HQ schedule and the standard allotment of 1 year of design and 1 year of construction, with additional time added for hazardous building materials survey and demolition. The HMBS will be necessary as this is an older building and could have been constructed with or developed toxins over time. Our budget estimate is $11 million for administrating, designing, and constructing the project with a commission price that is rounded 1.8% of the total project cost, which is standard and on the higher end of typical commissioning prices. This totals to a little under $11,300,000, which is on the higher end of renovating buildings this size, with consideration of ASHRAE sustainability targets. To further break down the $10 million allotted to each discipline's design and construction, we have allotted a general estimation based upon the number and scope of modifications in each discipline. We have chosen trusted manufacturers and subcontractors for the procurement of materials and installation, and the ones highlighted in yellow are industry partners of ASHRAE, in pink are local businesses to San Antonio. In regards to the electrical aspects of our newly renovated building, the OPR focused on a few main points. These consisted of resilience, on-site renewable energy, automated and sustainable lighting, and use of electricity, and most importantly, safety. The main challenges that came from this had to do with how we were going to balance efficiency and effectiveness with sustainability and safety. Solutions we came up with were to first establish renewable energy sources that we could consistently access for power, and for this, we chose solar energy. We then decided to set up an automation system for our lighting that requires some amount of motion over a certain period of time to stay on, as well as regulation on the amount of power that can be used throughout the office, which can be set and regulated by authorized administrators. Finally, we sought to regularly monitor and maintain all electrical systems, as well as isolate all electrical facilities so that they may only be reached by those with access to minimize risk of injury. Here's the mechanical systems we plan to implement for our building. Our HVAC and OR systems are set to be implemented across the entire building to provide improved indoor air quality and comfort for our occupants. Sensors and smart controls are designed to take note of our system's health to see if any maintenance is needed, and is also able to help our security and surveillance systems as well. We intend to use ASHRAE to use some preset designs at the beginning of our project, with the intent of replacing it with a more beneficial system as construction progresses. We will also take advantage of predictions for thermal loads, as taking note of occupancy, inside heat, local climate, and etc. to find the right indoor thermal loads to best fit the room. This fits along with our ventilation and HVAC systems, as they're set up to transfer the loads across the buildings to help build a comfortable area. Our BMS and BAS is also very important, as we want to prevent cyber attacks, find the most optimizable systems, beneficial algorithms, and better security system to have our building be safe and comfortable for future occupants. These are some of the technologies that we decided to implement for fire protection and plumbing. This includes a new rooftop water collection system. This will be part of a larger gray water system, which was more complicated as it was part of new construction. Through research, an effective integration strategy was created. The gray water system will function with a pump to distribute gray water from occupancy levels to the rooftop garden. The storage of filtered rainwater and gray water will be located on the roof in separate tanks to be out of sight and provide non-disruptive maintenance access. Gray water takes water that has been used but is still clean enough to be used for plants and distributes it where needed. The rainwater can be used as clean water once filtered in sinks, showers, etc. The given holistic approach to this project is the integrated design process. A design and construction that involves all disciplines, contractors and subcontractors early on in the design stage for the decision making process for systems, rather than letting each discipline choose and iron out conflicts overall. While IDP front loads time and frustration in the beginning of the project, the overall goal is to iron out potential conflicts early in the process to optimize efficiency, costs, and quality, and promote interdisciplinary collaboration. The owner's project requirements in regards to architectural systems had three main points: climate and site analysis, design strategies, and envelope design. Our team encountered several challenges in meeting these requirements, notably in interpreting the San Antonio climate and geotechnical reports, determining optimal insulation for walls and windows, and harmonizing aesthetic elements to seamlessly integrate with the building's environment, while still respecting its historical essence. The primary focus was keeping the building's charm and historical integrity while ensuring structural stability, sustainability, and innovation.
Shown here are some of the revised floor plan sketches that were done by the Cat Zero architect that depict the envelope design process. This is where we decided what parts of the original structure would be kept and which parts would be demolished. There are also some notes included that discuss possible changes. To achieve our goal of keeping the building's historical integrity while ensuring structural stability, sustainability, and innovation, we incorporated some of the following technologies. Our team chose to maximize daylighting and incorporate lighting shelves to elevate natural light during the day and provide a low lighting in the evening. In order to sustainably do this, we found it was important to install double pane windows to mitigate sound, enhance energy efficiency, and regulate heat intake within the building. Incorporating a biophilic design and a green roof was another intentional choice to ensure a seamless integration of the building with its surrounding environment. This was done to avoid a harsh transition from the renovation while also providing a space for occupants to decompress during the day. In order to achieve this desired biophilic design, we pulled inspiration from other buildings, the main one being the Zachary Engineering Education Complex and their green roof terrace, as seen in these images. Thank you for joining us today. We want to give a special thanks to our mentors, Joey Dorsch and Drew Shively, for their invaluable help. If you have any questions, please contact Maya Hernandez at maya98@tamu.edu.